The question is, if P implies negation of P or Q and this is false, the truth values of P and Q are, we are supposed to find the truth values of P and Q. Given statement is P implies negation of P or Q. So first let us draw the truth table for the conditions used. So first is implication and or. So let these two statements be A or B. So this will be TTFF and this will be TFTF. So A or B will be, for this condition both the statements should be false, then it is false, otherwise it is true. So FF is F for this one. For A implies B, TF is F, everything else is true. So this is the truth table for reference. So now it is given that P implies negation of P or Q is false. Now this is an implication statement, that is conditional statement, and the answer is false. But in the implication statement, the answer is false if and only if first statement is true and second statement is false. That is, P implies F is the only possible way of getting an answer F. So P should be true for this to happen, and negation of P or Q should be false. So you got P equals 2, so it can be either C or D. So P is true. Now we'll find Q. So P is true, so negation of P will be negation of true, or Q equals F. Negation of T is F, or Q equals F. Now this is an OR statement and the answer is F, and this is the only possible outcome where the answer is F. For this to happen, both the statements should be false. So here one statement is false, so therefore Q should also be false for this to happen, since F or F gives F. So Q is F, P is T. So the answer is D, E comma F. Now contrapositive of statement P or Q implies R is, contrapositive of this statement is given by, if this is a conditional statement, A implies B, then contrapositive is given as negation of B implies negation of A. So here A is P or Q and B is R. So given statement is P or Q implies R, then the contrapositive will be negation of R implies negation of P or Q. Now we expand the brackets, so this will be negation of R implies negation P, or negation of or is and, so negation of P and negation of Q. So the answer is option A, negation of R implies negation of P and negation of Q. The converse of the contrapositive of P implies Q is, now contrapositive of a conditional statement is given by A. If this is the conditional statement, A implies B, then contrapositive is given as negation of B implies negation of A, and for this converse is given as B implies A. That is, this is the converse of this implication statement. This states if A happens, then B will happen. Converse states the opposite, that is, if B happens, then A will happen. So first contrapositive of P implies Q. So P implies Q, contrapositive is negation of Q implies negation of P. Now converse of this is, we simply switch the statements, so this will be negation of P implies negation of Q, which is option C. Negation of P implies negation of Q. Let P be the statement roses are red, Q be the statement sun is a star. Then verbal translation of negation P or Q is, these are the statements. We have to convert this symbolic form into statement form. So P is, let us write this in symbolic form. So red is equivalent to R and sun is a star, B S. So P is R and Q is S. P means roses are red, and Q means sun is a star. So verbal translation will be, so negation of P will be roses are not red. And Q will be as it is, that is sun is a star. So negation of P or Q will be roses are not red, and this is the symbol of or. So or sun is a star, which is option D, roses are not red or the sun is a star. If it is raining, then I will not come. This is the statement which is given. The contrapositive of this statement will be, so first let us write this in symbolic form. So if this is raining, so let P be, P stand for raining, and Q stand for I will not come. So symbolic form will be, so this uses if then words. So this is a conditional statement. So symbolically it will be P implies Q. That is, if P happens, then Q will happen. That is, if it rains, then I will not come. So contrapositive form will be negation of P. Contrapositive is negation of Q implies negation of P. So writing this in the statement form, it will be negation of Q is I will not come. So negation of Q will be I will come. So I will come. And since this is a conditional statement, so we'll be using if. So if I will come, then negation of P, that is P is it is raining, so negation of P will be it is not raining. So if I will come, then it is not raining, which matches with the description of option A, which is if I will come, then it is not raining. Next statement is, if Ram secures 100 marks in maths, then he will get a mobile. The converse of the statement is, so the given statement is, if Ram secures 100 marks in maths, then he will get a mobile. So let P be, he gets 100 marks, and Q be, he gets a mobile. So statement says, this is a conditional statement since it uses if then words. So symbolic form will be P implies Q. So converse form will be, we simply switch places. So it will be Q implies P, but Q is he will get a mobile. So writing this in the statement form, it will be he will get a mobile, and since we are using a conditional statement, it will be if he, that is in case Ram, if Ram will get a mobile, then QP is he secures 100 marks. So this will be he secures 100 marks in maths, which is option C. If Ram will get a mobile, then he secures 100 marks. Let P be the proposition, that is statement, mathematics is interesting, and Q be the proposition, mathematics is difficult. Then the symbol P and Q stands for, so P is maths is interesting, and Q is maths is difficult. So what we are supposed to find is P and Q. So statement form will be maths is interesting, which is P, and maths is difficult, which is option C. statement P stands for a man is happy, Q stands for a man is rich. So this is given the symbolic representation of if a man is not rich, then he is not happy. So what is the statement is, if a man is not rich, then he is not happy. So keywords are this statement, and these two words. So if then is used, so it is a conditional statement for sure. Now a man is not rich. Q stands for a man is rich. So this is the inverse of this. Inverse of man is not rich, which is negation Q. So it starts with negation Q. And after then it is he is not happy. So he is not happy is negation of that is inverse of P. That is a man is happy. So this will be negation P. So symbolic form of if a man is not rich, then he is not happy is negation of P. Q implies negation of P. So the answer is B. Negation of Q implies negation of P. If P and Q are true statements, so it is given that P is true and Q is true. Then which of the following holds true? That is, we have to find which of the statement is true. So let us check one by one. So first option will not be using the truth table since it will be lengthy. So we'll using the basic rule for each statement. So for and, basic condition is T is T, that is A B. So T is T, that this is statement. So for and it is T is T, everything else is false. So for this to be true, this term should be true. So let's check if this is true. So Q is true. So negation of Q will be false. So this is false. This is not true. This is false. So if this is false, this cannot be true since both the values both the statements should be true in order for the answer to be true. So since this is false, then even if this is true or false, this will be always false. So this is not true. This is false. So option A is eliminated. Option B. Now this is false. Since Q is true, so this will be false. So for implication condition, conditional statement, that is TF is F. So for this to be true, now for table for implication statement is such that TF is F. So if this is F, this will turn true. So this should be true in order to be this should be false. Sorry, if this is true, if this is true and this is false, then the answer will be false. So we have to check if this is false also. So P or Q. So next statement is or condition for is FF is F. Remaining else is true. So here P is true, Q is true. So T or T is also true. Since both the statements should be false in order for the answer to be false. So this will be T or T will be T. So this is T and this is F. So this turns out to be T implies F, which is false. And this is not true. So B is also eliminated. Let's check C. So P and negation Q implies Q. So now this is T. For implication statement, A implies B, T, FF, TF. So DF is F, everything else is true. So if the second statement is true, then so this is true in this case. So irrespective of the condition of first statement, it is always true. If you can check this out here. So the second statement is true. So irrespective whether it is true or false, it is always true. So the answer is C. P and negation Q implies Q. Since after implication the statement which is made is true. So this can be either T or T implies T or F implies T. Both statements are true. P is a statement which says Ram is rich, Q is Ram is successful, and R is Ram is talented. So we have to write the symbolic form of this statement. Ram is neither rich nor successful and he is not talented. So let's first break down the statements. So Ram is neither rich nor successful. This is the first part of the statement. Ram is neither rich nor successful. This is alternative form for Ram is not rich and Ram is not successful. So symbolically we can write this as Ram is not rich is inverse of P which says Ram is rich. So Ram is not rich stands for negation of P and Ram is not successful. Ram is not successful is inverse of Q which says Ram is successful. So this will be and Q. And the remaining statement says and he is not talented. So and he is not talented says this is negation of R which says Ram is talented. So this is negation of R. So the final symbolic form will be negation of P and negation of Q and negation of R, which is option D. If P and negation Q implies negation of P or R is a false statement, then the truth values of P, Q and R are, first we'll draw the truth tables for each of the statements. So for let the statements be A and B. So first and condition. So A and B is, let this be TTFF and TFTF. So and statement is, if both the statements are true, then it is true. So TT is T, everything else is false. For OR, it is FF is F, that is both the statements should be false, then it is false. So FF is F, everything else is true. And for implication, that is A implies B, it is TF is F. TF is F, everything else is true. So this is a reference table. So now the given condition is P and negation Q implies negation of P or R. This is false. For this to be false, first statement should be true and second statement should be false, as we can see from the truth table. So first statement should be false, true, second statement should be false. So P and negation Q should be true. So this is the first part of the statement. So P and negation Q should be true. Now for this to be true, both the statements should be true. That is P should be true and negation Q should be true. So P will be true and negation Q will also be true, as seen from the table. So B is true. So answer is either A or C. So we got the truth value of P. Negation Q is T. Therefore Q will be negation of T, which is false. So Q is false. So answer is A, TFF, where P is true, Q is false, and this is the only statement where P it is the only option where P is given as true and Q is given as false. So let us also check the value of R. So this statement is false. So negation P or R is false. For this to be false, both the statements should be false. So R is false. So you can confirm this. So the answer is TFF, where P is T, Q is F, and R is also F. The statement says P is a triangle is equilateral, and Q says a triangle is equiangular. Then inverse of Q implies P is, so Q implies P is the given statement. We have to find the inverse. So symbolic form of this inverse is negation of Q implies negation of P. So symbolic for the statement form will be Q is a triangle is equiangular, so negation of Q will be a triangle is not equiangular. So since we are using if then condition, that is conditional statement, so we'll start with if. So if a triangle is not equiangular, then negation of P is negation of a triangle is not equilateral, which so this will be a triangle. P is triangle is equilateral, so negation will be a triangle is not equilateral. Writing it grammatically correct, we can say if a triangle is not equiangular, then it is not equilateral. So we'll check this, compare the statements. If a triangle is not equilateral, then it is not equiangular. This is what we want, the opposite of that. It should begin with the triangle is not equiangular. So statement B, if a triangle is not equiangular, then it is not equilateral triangle. So B is what we want, that is negation of Q implies negation of P. That is, if a triangle is not equiangular, which is negation P, then that is implies it is not equilateral, that is negation of P. P is a statement, boys are playing, and Q is statement, boys are happy. Then equivalent form of compound statement, negation of P or Q is, so statement is negation of P or Q. So negation of P is, so P is boys are playing, so negation will be boys are not playing. And we are using or, so this will be or. Q, boys are happy. So this is the sentence. Now we'll find the statement which matches with this description. So option A, boys are not playing or they are happy. So boys are not playing or they are happy. So answer is A. This matches with the description, that is boys are not playing, which is negation of P, or they are happy, that is Q. So A is answer, boys are not playing or they are happy. Logically equivalent statement of P double implication Q is, now P biconditional or double implication Q is P negation P or Q and negation Q or P. Now this is nothing but P implies Q, and this is nothing but Q implies P. So the equivalent form will be P double implication Q is the same as P implies Q and Q implies P, which is option C. The proposition P implies negation Q and negation P implies P is, so now we'll draw the truth table for this. So P, negation P, P implies negation P, negation P implies P, and let this be A, let this be B, so this will be A and B. So P can take values true or false, so negation will be false or true. P implies negation P is, P implies negation P, so negation for formula for negation P, TF is F. So this is F, everything else is false. So everything else is true. So TF is F and FT is T. Negation P implies P. So TF is F, everything else is true. So this is false and this is true. So and statement for these is both should be true, then it is true. So here neither of the statements are true, but neither of the cases are where both the statements are true. So this both of them are false. So since it consists of only false statement, then it is a contradiction, which is false statement, which is a false statement. So the answer is D, contradiction. P and negation Q, and negation Q and P is a, so let us draw the truth table. P, T, T, F, F, Q will be T, F, T, F. Negation P will be F, F, T, T, and negation Q will be F, T, F, T. So P and negation Q will be, let this be A. So P and negation Q, P and negation Q, so T, T is T. So here it is T, T is T, remaining else is false. Let this be statement A. Now negation P and Q. Negation P and Q. So again here both the statements should be true. So negation P true and Q true. So T, T is T, everything else is false. Now let this be B. So A, this is A and this is B. So A and B is what we have to find. So A and B. So both the statements should be true. But here there is no such case where both the statements are true. So everything else is false. So since it contains only false values, so this will be contradiction, which is option D, contradiction. The false statement in the following is, we have to find the statement which is false among these options. So let us check one by one. P and negation Q is a contradiction. So P and negation Q. So the statement used is and. For this to be true, both the statements should be true. So condition 1 is if this can be true, or second condition is this can be false. So when this is true, this is false, and when this is false, this is true, since this is a negation. So they cannot be true at the same time. So this cannot be true when this both the statements cannot be true. So this is always false. So since this is always false, it will be a contradiction. So statement A is correct, which says P and negation P is a contradiction. P, this is true. So let's check the second statement. P or negation P is a tautology. So P or negation P. For this to be false, both the statements should be false. Now, if this is false, then this will be true. And when this is true, this will be false. So it will never happen that both the statements are false. So this can never be false. So it will be always true. Since it is always true, it is a tautology. So B is also correct, which says P or negation P is a tautology. So this is true. Let's check third statement. Negation of negation P, double implication P. Now negation of negation P is P, biconditional statement, that is double implication P. So condition for biconditional statement is, if both the statements are true, then it is true. So here P and P are the same thing. So both the statements can be said to be true, said to be same. So the answer will always be true. So since the answer will always be true, it is a tautology. So C is also true. So since A, B and C holds true value, so D is the only false option. So the answer is D. P implies Q. Double implication negation of Q implies negation of P is a contradiction. And this is a false statement, since everything else is true. Which of the following statement is a tautology? So we have to find the statement which holds a true value. So let's check one by one. So first statement is negation of P, Q and P and Q. So we can rearrange this as negation of Q and P. So negation of q and q. So for and statement, both the statements should be true. Then only it will be true. Otherwise it is false. So here, this first of all, it cannot be true since these are inverse of each other. So if one is true, other is false, and if other is true, q is false. So this is always false for and. So this will be f and p. So for and condition to be true, both the statements should be true. But here it is clearly f, so it can never be true. So this is not a tautology. So option A is cancelled. Let's check option B. Negation of q and p and negation q. Now p and negation q is false since both the statements should be same and it should hold true value. So here they are clearly inverse of each other. So this is false, and irrespective of what is here, this is also false. Since this is false, both the statement cannot be true, so the answer will be false. So this is not a tautology. Now let's check C. So negation q and p, or p and negation q. Now p and negation q is again false, as we have seen before, or negation q and p. Now this statement can either be true or false. In either case, for an or condition, both the statements should be false. There's a correction here. It is third option is negation q and p, or p or negation q. So this is an or statement. So for this to be, so condition for or statement is for this to be false, both the statements should be false. So let's check first this term. So p or negation p. So this term, for this to be false, both the terms should be false. So here we can see both are negation. So this cannot have the same value. So therefore this is true, since both the statements should be false in order for this to be false. Else it is true. So this will be true, or so this may hold true or false value. Now again, since this is or statement, both the statements should be true, then only it will be false. But it has a true value, that is the second statement is always true. So this cannot be false, since both the statements are not false. So this cannot be false. So irrespective of what the first statement is, it is always true. So since it is always true, it is a tautology. So the answer is C, which is tautology, is negation of q and p or negation v. The only statement among the following is a tautology, and we have to find the statement which has a truth value, that is all true values. So we'll draw the truth table. So A will be TTFF, B is TFTF. So A or B will be, both should be F, FF is F, else it is true. And it is A and B, TT is T, else it is false. So this is for and. Now first option, A and A or B. So A and A or B. So here TT is T, else it is false. So this is not tautology. Second option, A or A and B. So this is A or A and B. Or, so FF is F in this condition. So FF is F, FF is F. and first two statements will be true. So again this is not a tautology. Now A implies B. A implies B is TF is F, else it is true. A and A implies B will be A and A implies B. So T is T, else it is false. So we got this part as TFFF, and this implies B. Let this be, say, P. Let this part be P. So P implies B. So this will be TF is F. So T, so it is false. FF, so it is false. FT, FF, so this is always false. So this is a contradiction which is there's a correction. The condition for implication statement is TF is F. See here, there is no, for in this case, there is no TF here. For P, when first statement is true, that is when P is true, B is not false. So this is true, and in the other statement similarly, it is also true. So we can see P implies B is always true. So this is a tautology. So P implies B is nothing but A, and A implies B implies B. So C is a tautology, which is our answer. The statement is P and Q or negation P and negation Q or P is negation Q and P is equivalent to what? So let's draw the truth table. PQ, P can be TTFF, Q is TFTF. So negation Q will be FTFT. So P and Q is TT is T, else it is false. Negation Q and P, negation Q and P, so if both are true, then it is false, then it is true, else it is false. Now here, if both are false, then it is true, then it is false, sorry. If both are false, then the statement is false, that is FF is F. So here there are two such cases, so FF, else it is true. Let this be A, let this be B, so this is A or B. So we have to find the statement which holds identical values. So starting with P, we can see it is TTFF and it is also TTFF. So P is equivalent to A or B, but A is P and Q or negation, and B is negation Q and P. So the answer is B, P. The statement P implies negation Q is equivalent to, these are the options. So in two of the options, implication statement is used. So we'll check for we will check for its contrapositive equivalent. So contrapositive for a implication statement is given as A implies B. So contrapositive is negation of B implies negation of A, and these both are equivalent. So first let's find the contrapositive of this statement. So P implies negation Q. So contrapositive will be negation of negation Q implies negation of P. So this is negation of P, that is equal to Q implies negation of P. Now A implies B is also equivalent to negation of A or B. So equivalent for this is negation of Q or B, that is negation of P. So if we compare it with the options, we'll find this to be the same as option B, that is negation of Q or negation of P. So the answer is B, negation of Q or negation of P. Negation of the statement given by he is rich and happy is, so let statement P be he is rich, statement Q be he is happy. So symbolic form will be he is rich and happy, so it will be P and Q. So this is the symbolic form of the given statement. So negation will be negation of P and Q, which is negation P, negation of and is or, so negation P or negation Q. So we should be looking for a statement which has the word or. So option A has and, so it is eliminated. Second option has but, which is a form of and, so it is also eliminated. C, he is not rich but happy, so but again it is a form of and, so again C is eliminated. D, either he is not rich or he is not happy, so this is the only statement which makes use of or, so D is our answer. So let's verify it. Either he is not rich, that is negation of P, or he is not happy, that is negation of Q. So D is our answer. Negation of statement Q or negation of P and R is, so given statement is Q or negation P and R. So negation will be Q or negation P and R. Bringing the negation inside the bracket, this will be negation Q, negation of or is and, negation of negation P and R. So negation gets cancelled. We are left with negation of Q and P and R, which is option B, negation Q and P and R. Negation of P or negation Q and Q is, so given statement is P or negation Q and Q. So we have to find the negation of this. So negation of P or negation Q and Q. So this will be negation of P or negation Q, negation of and is or, and negation of Q is negation Q. So now by De Morgan's law, we can say negation of P and negation of negation Q or negation Q. That is, we are bringing this negation Q inside the bracket. So this is equal to negation of P and negation of negation Q is Q or negation Q. Again, using De Morgan's law, we can say negation of P and Q or negation Q. So, which is option C. The given statement is P implies negation of P or Q. We have to find the negation of this statement. So First, we'll simplify the given statement. P implies negation P or Q. This is equivalent to negation of P or Q, that is negation of P or Q. So this is the simplified form. Now we use negation. So negation of P implies negation of P or Q is equivalent to negation of negation P or negation of P or Q. So now we bring negation into the bracket. So negation of negation P, negation of R is and negation of negation P or Q. So negation of negation P is P, and negation, again we bring the negation into the bracket. So negation of negation P, negation of R is and negation Q. This will be P and P and negation Q. Now P and P is P, since they are identical. So this will be P and negation Q, which is option D. If S of PQR is equivalent to negation of P or negation of Q and R, and this is a compound statement, then S of negation P, negation Q and negation R is, so we have to substitute P with negation P, Q with negation Q and R with negation R. So negation S of negation P comma negation Q comma negation R is, so negation P, instead of negation P we put negation of negation P, or negation instead of Q, negation Q, and negation R. Negation of negation P is P, or negation of negation Q and negation R, that is P or negation of, now we take negation out common, so this will be negation of P or R. This is equal to negation of negation is negation gets cancelled out, so this will be P or Q or R, which is option D. The negation of the proposition if 2 is prime then 3 is odd is, so first we'll write this in symbolic form. So statement is if 2 is prime then 3 is odd. So let statement P be 2 is prime, statement Q be 3 is odd. So symbolic form will be, if then is used, so it will be P implies Q. So this is symbolically equivalent to negation of P or Q. So we have to find the negation of this statement. So negation of P implies Q is negation of negation P or Q, that is equivalent to P and negation Q. So we convert this into statement form. So P is 2 is a prime number, so 2 is prime and 3 is not odd, since it is the negation of Q which says 3 is odd, so 3 is not odd. So the answer is B, 2 is prime and 3 is not odd. Negation of P double implication Q is, now P double implication Q is given by negation of P or Q and negation of Q, or negation of P or Q and negation of Q or P. So we have to find the negation of this. So negation of P double implication Q is negation of negation P or Q and negation of Q or P. So this will be bringing negation inside the bracket, negation of negation P or Q, or negation of and is, or negation of negation Q or P, bringing negation inside the bracket again. Negation of negation P is P, negation of or is and negation Q, or negation of negation Q is Q, negation of R is and, negation P. So the answer is P and negation Q or Q and negation P, which is option B. Negation of P and Q implies negation of P or R is. So first we'll write the equivalent form of implication statement. So A implies B is equivalent to negation of A or B. So we'll use this. So P and Q implies negation of P or R is equivalent to P and Q, negation of P and Q or negation of P or R. So we have to find the negation of this. So negation of P and Q implies negation of P or R is equivalent to negation of negation P and Q or negation P or R. Bringing negation inside the bracket, this will be negation of negation gets cancelled. So P and Q, negation of R is and, negation of negation P or R. So this is P and Q, and we bring negation inside the bracket. So negation of negation P is P, negation of R is and negation of R is negation R. So final answer is P and Q and P and negation R, which is option C. P and Q and P and negation R. Negation of the statement A is rich but silly is. So we'll break this down into two statements. So let P be A is rich and Q be A is silly. So the statement says P and Q, which is A is rich but silly, but is an alternative for and. So given statement is P and Q, we have to find the negation. So negation of P and Q is negation P or negation Q. That is, so in statement form it will be negation P is A is not rich or A is not silly. So let's check the options. Either A is not rich or not silly. Either A is not rich or not silly. So this is a form of and. So this is not valid. Let's check B. A is poor or clever. Now opposite of not rich is poor and opposite of not silly is clever. And this matches the description where it is given negation of P or negation Q, where A is poor is negation of P and A is clever is negation of Q. So the answer is B. A is poor or clever. Negation of negation P implies Q is, negation of negation P implies Q is, now this can be written as negation of P, negation of negation P or Q and negation of this. So negation of negation P is P. So this will be negation of P or Q. So taking negation into the brackets, this will be negation P, negation of R is and negation Q. So the answer is B, negation P and negation Q. Let P be the statement which says 7 is not greater than 4 and Q be the statement Paris is in France. Then negation of P or Q is the statement. So P is given as 7 is not greater than 4 and P is in Q is Paris is in France. So negation of what we are supposed to find is negation of P or Q. So we put negation inside the bracket. So this will be negation of P, negation of R is and negation of Q. So we have to write a statement which is equivalent to this symbol. So this will be negation of P is, now P is 7 is not greater than 4. So negation of P will be 7 is greater than 4. And Paris is in France is Q. So negation will be Paris is not in France. So the answer is D, which says 7 is greater than 4 and Paris is not in France. The following circuit represents symbolically in logic when the current flow in the circuit. So this is the circuit which is given. We have to find the symbol, the statement which represents the current flow through the circuit. So current will flow through the circuit either from upper branch or lower branch. For current to flow from upper branch, negation of P switch should be closed and negation of Q switch should be closed. Similarly, for the current to flow from the lower branch, P should be closed and negation Q should be closed. So path 1 for current is negation P is closed and Q should be closed. So symbolically it can be written as negation of P and Q. So this is one part where current will flow. Both should be closed. Part 2 for current flow is if these two switches are closed, that is P is closed and negation Q switch is closed. So current can flow through either part. So we'll be using now first symbolic form for this will be P and negation Q for part 2. Now current can flow either from part 1 or part 2. So part 1 or part 2 can be symbolically represented as current can flow through either one of these or both of these. Current will still flow. If all the 4 switches are closed or either only 2 adjacent switches are closed, current will flow. So this is possible for OR condition. So this will be path 1 or path 2. Symbolically we can write this as negation of P and Q since it is part 1, or part 2 which is P and negation Q. So this is the symbolic form when current flows through the circuit, and the option is D, negation of P and Q or P and negation Q. So this represents the current flow statement. The circuit diagram is given. We have to find the symbolic form. Now when the switches are in series, then we'll be using AND. When switches are parallel to each other, then we'll be using OR. So here P and Q are parallel, so this is P or Q. P and R are parallel, so this is P or R. Or because current can flow through either of the branches, that is current can flow through switch P or switch Q. Similarly, current can flow through either switch P or switch R. Hence we use OR. And for this, for current to flow from, let's say this is A and let's say this is B. For current to flow from A to B, they should be in series. So we'll be using AND. So the symbolic form will be P or Q and P or R, which is option A. Symbolic logical expression for the following switching circuit is, so simplified logic expression for the following switching circuit is, so we have to simplify the given circuit. So logically it can be represented as, now this is in parallel, so we can write P or P dash is negation P, and this is in series with Q, so AND. So we have to simplify this. So now this is OR. So we'll draw the truth table for OR. So P and P or negation P. So when P is true, this is false. When this is false, this is true. Now condition for P for OR is both should be false. then it is false. So here there is no such condition, so both will be true. So P or negation P is true, and that is equal to T and Q. This is equivalent to, now T and Q is, for circuit to flow, the condition should be true. That is T and Q should be true. Since T is T and T is T for AND condition, so T and Q should be equivalent to 2 for current flow. So both the terms should be true. So therefore Q must be true. So when Q is true, then Q is closed, so current will flow. So irrespective of the position of irrespective of the value of P, current will can still flow through Q. So the simplified form of the circuit will be, so this is equivalent to just Q. So simplified form will be this, and the answer is B, Q.